The most terrifying thing about the night sky isn't its size, nor is it the cold indifference of the vacuum that sits just 62 miles above your head. The most terrifying thing is the silence. When you walk out into a field on a clear, moonless night and look up at the band of the Milky Way, it looks peaceful. It looks static. It looks like a painting that was finished a long time ago and hung up for us to admire. But that is a deception. That silence is a lie. If your eyes could see the history of what you were looking at, if your ears could hear the echoes of where all this came from, you wouldn't be standing there in awe. You would be on your knees, overwhelmed by the sheer violence of our origin. Because the story of the universe does not begin with a whisper. It begins with a scream so loud that it shattered the very concept of nothingness. A scream that is still ringing in the static between radio stations. A scream that is the only reason you and I are here to have this conversation. We are going to go back to that moment. We are not just going to talk about the physics. We are going to try to feel the texture of that first impossible second. We are going to walk back through the dark, past the birth of the earth, past the lighting of the first stars, past the great fog of the early cosmos, until we hit a wall of fire and mystery, where the laws of nature themselves break down. Now, ask yourself, how long can you hold your breath before your lungs scream? 30 seconds? A minute? That feeling of pressure building up in your chest, that desperate, panic-inducing need to expand, to let air in, to break the seal, that is the closest human sensation we have to the state of the universe at the very beginning. Imagine that feeling of chest-crushing pressure, but multiply it by infinity. We are taught in school that the universe began with the Big Bang, and the image that pops into our heads is usually an explosion. We imagine a stick of dynamite going off in an empty room, sending shrapnel flying out into the void. But this is the first thing we have to unlearn. There was no room. There was no void for the shrapnel to fly into. There was no outside. When we speak of the beginning, we are speaking of the moment when here and there were the same place. We are speaking of a moment when the entire stage of reality, the very fabric of space and time that we move through today, was folded up into a point so small that it had no dimensions at all. To understand this, we have to play the movie of our lives in reverse. Imagine we have a remote control that controls the flow of time. We press rewind. We watch the sun set in the east and rise in the west. We watch the raindrops fly up from the puddles back into the clouds. We speed it up. We watch the continents drift back together into Pangaea. We watch the dinosaurs rise from the dust and then disappear back into biology. We watch the earth melt back into a ball of magma and then disperse into a cloud of dust around a young sun. We keep going back. The universe is getting smaller. The galaxies are rushing toward each other. The vast, lonely distances between the stars, distances that currently make it impossible for us to ever leave our solar system, are shrinking. The universe is becoming a crowded room. As we approach 13.8 billion years ago, everything that currently exists, every drop of water, every grain of sand, every black hole, every photon of light, is being squeezed into a space smaller than the period at the end of this sentence. And we keep going. The heat is rising. The pressure is becoming absolute. We are approaching the singularity. Here is a number that might scare you. The entire visible universe, everything you can see with the most powerful telescope, was once packed into a region smaller than a single proton. A proton is a subatomic particle. It is effectively invisible. If you took everything that makes up you, the Earth, the Sun, and the billions of galaxies, and crushed it down that small, you would create something that physics calls a singularity. This is the monster at the beginning of the book. A singularity is a point where the curvature of space becomes infinite. It is a place where density becomes infinite. And when mathematicians and physicists see the word infinite in their equations, they don't celebrate, they panic. Infinity is not a number, it is a sign that our understanding has failed. It means the math has broken. It means the rules of the game no longer apply. At the singularity, gravity is so strong that it doesn't just pull things together. It crushes the concept of time itself. There is no before this moment. This is the hardest concept for us to grasp because we are creatures of time. Our entire consciousness is built on the scaffold of cause and effect. We are born, we live, we die. Yesterday caused today, and today causes tomorrow. So when we look at the beginning of the universe, our human brain naturally asks, what happened before the Big Bang? What was sitting there waiting to explode? It is a sensible question, but in this context, it is a meaningless one. It is like asking, what is north of the North Pole? If you stand on the North Pole and take a step, you are moving south. There is no north of the North Pole. It is not that there is a wall there preventing you from going further. It is that the geometry of the Earth makes the question invalid. In the same way, asking what came before the Big Bang is assuming that time is a straight line that stretches back forever. But time is not a straight line. Time is a property of the universe, just like heat or light. If the universe doesn't exist, time doesn't exist. There was no before because there was no clock to tick. There was only the singularity, suspended in a state of existence that we cannot describe with words, because words require time to be spoken. But what if we are looking at this upside down? What if the Big Bang wasn't a loud explosion, but a silent unfolding? The term Big Bang was actually coined as a joke, a mockery by a scientist named Fred Hoyle, who didn't believe the theory. He thought the idea of the universe having a beginning was ridiculous. He preferred the idea of a steady-state universe, one that had always been here and always would be. And in a way, his instinct was comforting. A universe that always exists is a safe universe. It implies permanence. It implies that we are part of an eternal story. But the evidence told us something far more unsettling. The evidence told us that the universe is not a static mansion, but a burning building. We found the smoke. We found the radiation left over from the fire. We discovered that the galaxies are flying away from us, which means yesterday they were closer, and the day before that, closer still. This realization forces us to confront the fragility of our position. If the universe had a beginning, it implies it might have an end. If it was born, it can die. And we, the tiny accidental observers on this wet rock, are just watching the fireworks. So let us try to stand at that precipice. The moment is t equals 0. The temperature is infinite. The density is infinite. Then the clock starts. It moves from 0 to something impossibly small, 10 to the power of minus 43 seconds. This is known as the Planck Epoch. This is the great fog of physics. We literally cannot see what happened here. It is not because our telescopes aren't good enough. It is because our theories aren't good enough. In our current understanding of the world, we have two rule books. One is general relativity, written by Albert Einstein, which explains the big things: gravity, stars, galaxies, the curvature of space. It is a beautiful, smooth theory. The other rule book is quantum mechanics, which explains the tiny things: atoms, electrons, the subatomic jitter of reality. It is a chaotic, probability-based theory. Usually, these two rule books don't have to talk to each other. Gravity is too weak to matter to an atom, and atoms are too small to affect the orbit of a planet. they stay in their own lanes. But in the Planck Epoch, the universe is so small and so heavy that the large and the small are forced to collide. You have the mass of a galaxy squeezed into the space of an atom. You need general relativity because of the gravity, but you need quantum mechanics because of the size. And when you try to combine them, the math screams. It produces nonsense. It gives us probabilities larger than 100%. It gives us distances shorter than zero. It tells us that space itself was not smooth, but a churning, boiling foam in the Planck Epoch. There was no such thing as left or right, up or down. Space was a tangled knot of wormholes and quantum fluctuations, appearing and disappearing instantly. It was a chaotic storm of geometry. This is the era of the unknown. It is the dragon on the map. We suspect that in this fraction of a second, all the forces of nature, gravity, electromagnetism, the nuclear forces, were melted together into one single superforce, a master key of physics. We have spent billions of dollars building particle accelerators like the Large Hadron Collider to try and break this code, to try and recreate the temperatures of that first moment, just to get a glimpse of that unity. But we are still knocking on the door. Now, ask yourself, why is there something rather than nothing? This is the philosophical weight that hangs over the Planck Epoch. In a true vacuum, in a universe of absolute nothingness, there should be peace. No energy, no matter, no suffering, no stars, just a perfect black zero. But quantum mechanics tells us that nothing is unstable. Even in a perfect vacuum, particles pop in and out of existence. They borrow energy from the future and pay it back in the past. They are ghost particles, flickering like a bad fluorescent light. This is called the quantum vacuum. It suggests that the natural state of reality is not silence, but a hum, a vibration. And somewhere in that ancient, timeless nothingness, a fluctuation happened that didn't fade away. A bubble formed in the foam, a seed of energy that refused to pay its debt back to the void. This was the spark. This was the moment the universe decided it wanted to exist. We often feel insignificant when we look at the cosmos. We feel small against the backdrop of billions of years. But consider the precision of this moment. If the conditions in that Planck Epoch had been slightly different, if the force of gravity was a tiny bit stronger, or the expansion a tiny bit weaker, the baby universe would have collapsed back in on itself instantly. It would have been a firework that fizzled out in the tube. If the expansion had been a tiny bit faster, the matter would have flown apart so quickly that no atoms could ever form. There would be no stars, no galaxies, no carbon, no you. We are walking a knife edge. The physics of the beginning looks suspiciously fine-tuned. Some people call this luck. Some call it the anthropic principle. The idea that we see the universe this way because if it were any other way, we wouldn't be here to see it. But whatever you call it, it adds a layer of melancholy to our existence. We are the survivors of a cosmic lottery that had trillions of losing tickets. As we move past the Planck Epoch, the clock ticks to 10 to the power of minus 36 seconds. The universe is cooling, and as it cools, something dramatic happens. The superforce begins to break apart. Gravity is the first to leave the party. It separates from the other forces and becomes the weak, distinct force we know today. The force that keeps your feet on the ground but can be defeated by a simple fridge magnet. This separation is a violent event. It is a phase transition. Think of it like water turning into ice. When water freezes, it releases latent heat. It changes its structure. The universe underwent a similar phase transition, but on a scale that defies logic. The separation of the forces released a tsunami of energy. The vacuum of space itself shifted. It went from a false vacuum, a high energy state, to a true vacuum. And that shift, that sudden drop in the energy level of the cosmos, acted like a piston. This is the moment the silence ended. This is the moment the lungs let go of the breath they had been holding. The energy released by this separation of forces didn't just heat things up, it grabbed the fabric of space and ripped it open. This is the beginning of inflation. It is the most violent, rapid, and inexplicable event in the history of the universe. Up until this point, the universe was a calm, dense point. Now, it is about to expand faster than the speed of light. And I know what you are thinking. Nothing can travel faster than the speed of light. That is true for things in space. You cannot fire a bullet faster than light. You cannot fly a rocket faster than light. But space itself, space has no speed limit. Space can do whatever it wants. And in this fraction of a second, space decided to grow. Imagine a balloon. Not a normal balloon, but a balloon that starts the size of a virus and inflates to the size of the Milky Way galaxy in less time than it takes for light to cross the nucleus of an atom. That is the scale of inflation. It took the quantum jitter, the tiny microscopic bumps in the early universe, and stretched them out. It took the subatomic chaos and smoothed it into the canvas of the cosmos. This is why the universe looks the same in every direction today. If you look left, you see galaxies. If you look right, you see galaxies. The temperature is roughly the same. The density is roughly the same. This shouldn't be possible. The universe is too big for the left side to know what the right side is doing. There hasn't been enough time for heat to travel from one side to the other to even things out. It's like finding a cup of coffee on your desk that is exactly the same temperature as a cup of coffee in Paris. It implies they were once in the same pot and were separated instantly. Inflation explains this. Everything was touching. Everything was the same pot. And then, in a heartbeat, it was torn apart. This era of inflation is the bridge between the unknown and the known. It is the mechanism that turned the singularity into a universe. But it was not gentle. It was a period of cold expansion. The universe didn't contain particles yet. It contained a field, the inflaton field, filled with potential energy. It was empty, dark, and stretching at a rate that makes the human mind go numb. If you were there, you wouldn't have seen a flash of light yet. You would have felt a stretching, a tearing, the coordinates of reality moving away from each other. And then, just as quickly as it started, it stopped. The energy that was driving this expansion ran out. The inflaton field decayed. And when energy decays, it has to go somewhere. It cannot be destroyed. So, where did all that energy go? It was dumped into the empty vacuum. This is the reheating. This is the actual bang in the Big Bang. The energy of the expansion was suddenly converted into a soup of raw particles. Quarks, gluons, electrons, neutrinos. The universe suddenly lit up. It went from cold and empty to hot and crowded. A temperature of 10 to the power of 32 Kelvin. A heat so intense that atoms could not exist. Matter could not exist. There was only a plasma, a blindingly bright, incredibly dense soup of fundamental particles smashing into each other. This is the moment the universe became real in the sense that we understand it. This is where the ingredients for you and me were cooked. But there is a tragedy here too, because when this energy converted into matter, it didn't just create matter, it created antimatter. For every particle of matter created, every electron, every quark, The universe created a twin, an antiparticle, an anti-electron, an antiquark. These twins are identical to normal matter, but with an opposite electrical charge. And here is the problem. When matter and antimatter meet, they annihilate. They destroy each other instantly, turning back into pure energy. So the early universe wasn't just a kitchen. It was a battlefield, a war of annihilation. Trillions of particles were popping into existence only to collide with their twins and vanish in a burst of light. It was a cosmic stalemate. By all the laws of physics we know, this war should have ended in a draw. All the matter should have cancelled out, all the antimatter. The universe should have been left as a sea of light, with no matter left over to make stars or planets or people. We should not be here. The fact that we exist is a statistical anomaly. So, as we stand here, looking back at the first fraction of a second, we have to appreciate the precariousness of it all. We survived the singularity. We survived the chaotic fog of the Planck Epoch. We survived the tearing violence of inflation. And now we are surviving the great war between matter and antimatter. The universe is screaming. It is a blinding, hot, dense plasma, expanding outward, cooling as it goes. The silence of the beginning is long gone. The first act is over. The stage is set. But the universe is still a trap. It is opaque. Light cannot travel. Information cannot move. We are trapped in a glowing fog, and the most important element, the architect of the universe, is about to wake up. Gravity. Gravity has been weak, overwhelmed by the violence of the expansion. But as the fireball cools, gravity begins to whisper. It begins to look at the tiny irregularities left behind by the inflation. It begins to pull. We are about to enter the era where the universe builds its skeleton. We are about to see how the chaos of the beginning was tamed into the majestic structures we see in our telescopes today. But to understand that, we have to understand what happened when the universe finally cooled down enough to let the light go. We have to understand the moment the fog lifted, but before the light, there was the heat. And that heat is about to do something extraordinary. It is about to forge the first nuclei, the first heavy anchors in a sea of energy. The clock is ticking. We are still less than 1 second old. The universe is still smaller than the solar system. But the blueprint for your blood, your bones, and the gold in your wedding ring is being drawn right now in the fire. The breath has been released, and now the universe begins to roar. We are now standing inside the most violent machine in history. The timer on the wall reads 1 second. The universe is a blinding, screaming soup of radiation and particles, expanding outward with a ferocity that defies imagination. But something critical is about to happen. The temperature has dropped to 10 billion Kelvin. That sounds hot, and it is, but for the universe, it is the first chill of winter. It is the moment when the chaos cools just enough for structure to begin. Up until this second, the universe has been a simple place. It was just energy and fundamental particles smashing into each other. But now we are entering the era of the first marriage. We are entering the era of nucleosynthesis. So this is the first 3 minutes. And in these 3 minutes, the universe will decide the chemical composition of the cosmos forever. Imagine a game of musical chairs played at the speed of light. The players are protons and neutrons. The music is the intense heat that keeps them moving. As long as the music plays, as long as the heat is high, they bounce off each other, they cannot stick. But as the universe expands, The heat drops. The music slows down. Suddenly, a proton and a neutron crash into each other, and instead of flying apart, they hold hands. They stick. They form the nucleus of a new element called deuterium, or heavy hydrogen. This is a fragile union. In the first few seconds, the radiation is still so intense that it smashes these couples apart as soon as they form. It is a race. The universe is trying to build the first blocks of matter, but the heat is trying to destroy them. This is known as the deuterium bottleneck. It is a moment of cosmic hesitation. If the universe stays this hot, nothing complex can ever exist. We would remain a soup of lonely particles forever. But the expansion saves us. The expansion acts as the cooling vent. The temperature drops just below the danger zone, and suddenly the deuterium survives. Now, ask yourself, how fast can you build a world before the cement dries? Because the universe only had a window of about 3 minutes. That is it. 3 minutes to forge all the matter that would eventually fill the stars. Once the deuterium stabilized, it quickly grabbed more particles. 2 deuterium nuclei smashed together to form helium-4, trace amounts of lithium were created, and then silence, the fusion stopped. The universe became too cold to fuse anything heavier and too empty for particles to find each other. The window slammed shut. This is a haunting thought. In that brief, frenzied window, the universe created a specific recipe, roughly 75% hydrogen, 25% helium, and a tiny pinch of lithium. That is all we got. There was no carbon to make your DNA, no oxygen to fill your lungs, no iron to make your blood red, no silicon to make the computer you are listening to. The universe was sterile. It was a vast, expanding cloud of gas that contained absolutely no potential for life. Here is a number that might scare you. For every 1 billion protons in the early universe, there was only one single neutron left to pair with them. The rest had decayed. This imbalance is the reason the universe is mostly hydrogen. If the balance had been equal, all the hydrogen would have fused into helium. There would be no water. There would be no stars like our sun, which runs on burning hydrogen. The universe would be a boring, inert place filled with helium balloons. The fact that we have water, the fact that we have long-burning stars, is entirely due to a slight imperfection in the first few minutes of time. We are the children of a broken symmetry. But the creation of these first elements did not bring clarity. It brought a prison. We are now moving from the first few minutes into the next 380,000 years. This is the photon epoch. And if you were to open your eyes in this epoch, you would see nothing. Not because it was dark, but because it was too bright. The universe was filled with a glowing, white-hot fog. It was a plasma. In a plasma, electrons are stripped away from their atoms. They roam freely, and electrons are the enemies of light. Light is made of photons, and photons like to travel in straight lines. But when a photon meets a free electron, it bounces, it scatters. Imagine trying to run in a straight line through a crowded concert hall where everyone is moshing. You wouldn't get far. You would bounce from person to person, changing direction constantly. That is what light was doing for 380,000 years. It was trapped in a pinball machine. This is the cosmic fog. It implies that for nearly 500,000 years, the universe kept a secret. It was buzzing with energy, with information, with the fingerprints of the Big Bang, but it wouldn't let that information out. It held it close. This creates a horizon of knowledge for us. When we look back with our telescopes, we can see galaxies from billions of years ago. We can see the first stars. But we cannot see past this wall of fog. We cannot take a picture of the Big Bang itself because the light from that moment was trapped, bouncing around in the plasma dungeon. We are cut off from our own birth. We are like children trying to remember the moment we were born, but finding only a blur of white light. But what if we are looking at this upside down? What if this prison wasn't a cage, but an incubator? Inside this hot, dense fog, sound waves were traveling. Giant pulses of pressure were moving through the plasma, driven by the gravity of dark matter. These sound waves were compressing the gas in some places and rarefying it in others. They were creating the seeds of the galaxies. If the light had been free to escape instantly, the radiation pressure might have smoothed everything out too much. The fog kept the universe contained just long enough for gravity to dig its claws in. It allowed the blueprint of the cosmic web to be drawn in the dark. The universe was humming. A deep, resonant B-flat, roughly 57 octaves below middle C, a song of gravity and pressure that rippled through the entire cosmos. Then the moment of release arrived, 380,000 years after the beginning. The universe has expanded enough that the temperature drops to around 3000 Kelvin. This is a critical threshold. It is cool enough for the electrons to slow down. They are tired of running. The atomic nuclei, the hydrogen and helium we made in the first 3 minutes, finally catch them. An electron falls into orbit around a proton. Click, the first neutral atom is born. This is called recombination. And the moment the electrons are captured, the crowd disappears. The obstacles are gone. The photons of light, which have been bouncing around for eons, suddenly see a clear path. The fog lifts. The universe becomes transparent. In that instant, a flash of light was released from every point in the cosmos simultaneously. It wasn't a flash from a single explosion. It was the entire universe glowing and then suddenly letting go. This light began to travel. It traveled through the newborn darkness. It traveled while the first stars were being born. It traveled while the galaxies collided. It traveled while the earth formed from dust. It traveled while the dinosaurs rose and fell. It traveled while you were born. And today, 13.8 billion years later, that light is finally hitting the earth. We call this the cosmic microwave background, CMB. It is the oldest light in the universe. It is the afterglow of the Big Bang. But here is the tragedy of time. Because the universe has been expanding for so long, that original white-hot light has been stretched. It has lost its energy. It started as visible light, but as space stretched, the waves lengthened, they became infrared, then microwaves. Today, that screaming fire of the beginning arrives at our antennas as a faint, cold whisper. It is a temperature of 2.7 Kelvin above absolute zero. It is almost nothing, but it is everywhere. If you turn on an old television set, the kind with the bunny ears, and tune it to a channel that doesn't exist, you see static, a chaotic war of black and white snow. About 1% of that static is the cosmic microwave background. You are literally watching the Big Bang. You are watching the moment the universe let go of the light. The discovery of this light is one of the most beautiful accidents in science. In the 1960s, two radio astronomers, Arno Penzias and Robert Wilson, were building a giant antenna to communicate with satellites. But they had a problem. No matter where they pointed their antenna, they picked up a persistent hiss, a low-level noise that wouldn't go away. They thought it was the city. They thought it was the radar from a nearby airport. They even climbed into the giant horn antenna with brooms to scrub off white dielectric material, which is a polite scientific term for pigeon droppings. They evicted the pigeons. They cleaned the machine. But the hiss remained. It came from the day. It came from the night. It came from the empty spaces between the stars. It was the universe itself humming the song of its creation. They had accidentally stumbled upon the fossil of the first day. Now, ask yourself, have you ever felt the weight of a ghost? Because that is what the CMB is. It is a ghost of the past that haunts every cubic centimetre of space. It is a snapshot of the universe when it was just a baby. When we map this light today, we see a mottled blue and orange oval. It looks like an abstract painting, but those splotches are not random. The slightly warmer spots, orange, are places where the gas was a tiny bit denser. The slightly cooler spots, blue, are places where it was a tiny bit emptier. These tiny fluctuations, variations of just 1 part in 100,000, are the seeds I spoke of earlier. The orange spots are where gravity would eventually win. They are the places that would collapse to form galaxy clusters, superclusters, and eventually the Milky Way. If the cosmic microwave background had been perfectly smooth, perfectly one colour, gravity would have had no purchase. The gas would have stayed a gas. No stars would have formed. We are here because the baby universe was slightly lumpy. But as this first light streamed out into the void, something else happened. The universe went dark, truly dark. This is the start of the Dark Ages. We have left the era of the glowing plasma, and we have not yet reached the era of stars. There are no suns to light the sky. There are no galaxies. There is only a vast, expanding ocean of neutral hydrogen gas. If you were floating in space during this time, you would see absolute blackness. No moon, no Milky Way, no twinkle. Just a silence that stretched for hundreds of millions of years. It is difficult for us to comprehend this level of loneliness. We are creatures of the light. Our planet is bathed in it. Our biology craves it. But for a huge chunk of its history, the universe was a tomb. It was waiting. In the dark, gravity was working its patient magic. It was drawing the hydrogen atoms together, slowly, painfully slowly. One atom pulling on another, a cloud forming, a cloud getting denser, the center of the cloud getting hotter. The sound of the universe had stopped, replaced by the silent, relentless contraction of matter. This period is the great gap in our family tree. We have the baby picture, the CMB, and we have the adult picture, the modern galaxies. But the teenage years, the dark ages, are missing. We are building massive new telescopes, like the James Webb and the upcoming Square Kilometre Array, specifically to peer into this darkness. We want to see the first moment the lights turned on. We want to see the cosmic dawn, because somewhere in that velvet blackness, the first spark ignited. But before we get to the stars, we must confront what is missing. The universe created during the Big Bang was defective. It was incomplete. As I mentioned, it was just hydrogen and helium. It was a gas that could not build a planet. You cannot stand on a cloud of hydrogen. You cannot build a bone out of helium. The universe had plenty of fuel, but no building materials. It was a house made of gasoline, with no wood, no brick, no glass. For life to be possible, for us to be possible, alchemy was needed. The universe needed to figure out how to turn light gas into heavy metal. It needed a furnace. And this brings us to the profound realization of our own nature. We often think of ourselves as separate from the universe. We are in the universe, but we are the universe. The atoms in your right hand and the atoms in your left hand likely came from different stars, but they all started here in this dark, silent ocean of hydrogen. The story of the Dark Ages is the story of the universe pregnant with potential, waiting for the pressure to become great enough to force a change. It is a story of accumulation. It is the deep breath before the second scream. The Dark Ages were not empty. They were heavy. They were filled with dark matter. We cannot see it. We cannot touch it. And to this day, we don't know what it is. But we know it was there because of the shadows it cast. Dark matter was the scaffolding. It clumped together first, creating deep gravitational wells. The normal matter, the hydrogen gas, flowed into these wells like water flowing into a valley. Without dark matter, the normal matter would have been blown apart by the expansion. Dark matter held the universe together. It was the silent, invisible guardian that cradled the gas clouds until they were heavy enough to collapse. It is the ghost that built the house we live in. So, we leave the universe in darkness. 200 million years have passed. 300 million years. The gas clouds are getting tighter. The centers are heating up. The temperatures are rising from hundreds of degrees below zero to thousands of degrees. The pressure is building. The hydrogen atoms are being squeezed so tightly that they are starting to panic. They are vibrating violently. The silence is about to break. We're on the verge of the most important event since the Big Bang itself. We are on the verge of the first sunrise. But this sun will not be like our sun. It will be a monster, a giant, blue, short-lived beast that will burn with the fury of a million suns. And in its heart, it will finally begin the work of making us. The fog has lifted. The screen is dark, but in the center of the darkness, a spark is catching. The furnaces of memory are about to be lit. The universe is now a ghost town. The blinding heat of the Big Bang has faded into memory, and the first flash of light, the cosmic microwave background, has stretched out into the invisible infrared. We are left with a cosmos that is cold, vast, and terrifyingly black. This is the era of the Dark Ages. If you could hover in space during this time, you would see absolutely nothing. No stars to navigate by, no galaxies to anchor your eye. Just an endless, suffocating ocean of hydrogen gas. It is the longest night in history. For humans, darkness is usually a temporary state. We wait for the sun to rise. We flip a switch. But the universe had no switch to flip. It had to build the switch from scratch, atom by atom, in a vacuum that was fighting to pull everything apart. Now, ask yourself, have you ever felt truly alone in a dark room? I don't mean the kind of alone where you know your family is in the next room. I mean the kind of primal solitude where you feel like the only conscious thing in existence that is the mood of this era. The universe is holding its breath. It is expanding, getting colder and lonelier by the second. But underneath this silence, a massive, invisible construction project is underway. We cannot see it with our eyes, but we can feel it with our math. This is the work of dark matter. I mentioned dark matter earlier, but here, in the dark, is where it truly becomes the hero of the story. Without dark matter, the universe would have remained a thin, boring soup forever. Normal matter, the stuff you and I are made of, is actually quite hot and bouncy. It pushes back when you squeeze it. If gravity tried to pull a cloud of hydrogen gas together, the gas would heat up, the pressure would rise, and it would bounce back out. It would refuse to collapse. Gravity was too weak to win this fight on its own. It needed a ringer. It needed something that had mass but didn't care about heat or pressure. Dark matter doesn't collide. It doesn't glow. It doesn't bounce. It just sits there, heavy and silent, creating a deep gravitational pit. But what if we are looking at this upside down? The darkness wasn't empty. It was heavy with the gravity that would build our home. Picture a mattress. Now picture placing a heavy bowling ball in the center. The mattress curves. That bowling ball is a clump of dark matter. Now imagine pouring a bucket of marbles onto the mattress. The marbles roll down the curve and gather around the bowling ball. The marbles are the hydrogen gas. This is what happened in the Dark Ages. The dark matter formed a vast, invisible web, a skeleton of filaments stretching across the cosmos. And the normal matter, the gas, simply flowed down the gravitational drains into the wells created by the dark matter. It was a cosmic trap, and once the gas was trapped, it couldn't escape. It began to pile up. It began to get dense. Here is a number that might scare you. The universe remained a pitch-black ocean for 400 million years. That is a time span roughly equivalent to the time between the first life appearing on land and you listening to this sentence. For all that time, nothing happened on the surface. But in the hearts of these dark halos, the temperature was rising. The hydrogen atoms were being crushed together. The pressure was mounting. The gas clouds were spinning, flattening into disks. And then, in one specific, nondescript corner of the universe, the threshold was crossed. The crushing force of gravity finally overcame the thermal pressure of the gas. The core of a cloud reached 10 million degrees Kelvin. The hydrogen atoms didn't just bump into each other, they fused, a nuclear fire ignited. And for the first time in nearly 500 million years, a photon of visible light was born, not from the Big Bang, but from a star. This was first light, but these were not stars as we know them. These were monsters. Astronomers call them population 3 stars. Our sun is a yellow dwarf, a polite, stable star that burns slowly for billions of years. Population 3 stars were the rock stars of the cosmos. They were composed of pure hydrogen and helium with no heavy elements to dirty them. Because of this purity, they could grow to immense sizes, hundreds, perhaps 1,000 times the mass of our sun. They were blue giants, burning with a ferocity that is hard to comprehend. They lived fast and died young, burning through their fuel in just a few million years. But in their brief lives, they did something critical. They declared war on the dark. These giant stars were so hot that they poured out ultraviolet light like a flood. But this light didn't just travel, it attacked the surrounding gas. Remember, the universe was filled with neutral hydrogen, atoms with electrons firmly attached. The UV light from the first stars hit these atoms and knocked the electrons off again. It ionized the gas. This is called reionization. It is a beautiful image. Bubbles of clear, ionized plasma growing around the first stars, expanding outward, eating away at the fog of the dark ages. It was like watching holes appear in a dark curtain, letting the light stream through. But these stars were also the first suicides. They were too big to survive. When a star that massive runs out of fuel, it doesn't just fade away. It collapses instantly. The core implodes, and the outer layers are blasted into space in a hypernova, an explosion so bright it can outshine an entire galaxy. And in the heart of that explosion, something terrifying is born, a black hole. The very first stars left behind, the very first black holes, these were the seeds. These black holes began to feed on the gas around them, growing fatter, merging with each other, eventually becoming the supermassive black holes that sit at the center of every galaxy today, including our own Milky Way. Now, ask yourself, is destruction necessary for creation? Because the death of these first stars was the most creative act in the history of the universe. When they exploded, they didn't just release light, they released ashes. Deep inside their cores, before they died, these stars had squeezed hydrogen into helium, and helium into carbon, and oxygen when they blew up. They scattered these new elements across the universe. They salted the cosmos. The next generation of stars that formed wasn't pure anymore. They had a little bit of dust. They had a little bit of heavy metal. This changed everything. It allowed smaller, more stable stars to form. It allowed the universe to calm down. As the fog of the dark ages cleared, we began to see the structure of the universe revealed. The dark matter web was now lit up by millions of galaxies. This is the cosmic web we see in computer simulations today. Great filaments of light stretching across the void, with clusters of galaxies at the intersections, like sparkling jewels. It looks like a neural network. It looks like a brain. Gravity had successfully sculpted the chaos of the Big Bang into a majestic architecture. But it was a violent beauty. Galaxies were crashing into each other, merging, their central black holes spiraling together and shaking the fabric of space-time with gravitational waves. The universe is now about 1 billion years old. It has a shape, it has light, it has the chemical ingredients for complexity beginning to drift through the void, but it is still a hostile place. The radiation is intense. The explosions are frequent. It is a place for physics, not for biology. We are still a long way from the quiet blue marble of Earth. We are still a long way from a mind that can wonder about all of this. To get there, we need to zoom in. We need to leave the grand scale of the cosmic web and focus on a single, unremarkable patch of space. We need to watch a specific cloud of dust collapse. We need to watch the birth of a specific star, our star. But before we arrive at our own solar system, we must understand the sacrifice involved. The universe is a recycling machine. Every atom in your body was once part of a star that had to die. The calcium in your bones, the iron in your blood, the carbon in your genes, none of it existed at the beginning. It was all forged in the nuclear furnaces of stars that lived and died billions of years before the Earth was even a thought. We are, quite literally, ghosts of the past. We are the ash of dead stars, reassembled into something that can speak. This realization changes how we look at the night sky. We are not looking at alien worlds. We are looking at our ancestors. We are approaching the moment of our own origin. The universe has spent billions of years building the stage. The dark ages are over. The lights are on. The heavy elements are drifting through the galaxy like seeds in the wind, looking for a place to land. And in one spiral arm of the Milky Way, a cloud of gas and dust is becoming unstable. It is about to collapse. It is about to form a yellow star and a family of planets. And on one of those planets, the universe is about to try its most dangerous experiment yet. It is about to wake up. We are standing on the edge of a cliff, looking down into a swirling vortex of gas and dust. The year is roughly 4.6 billion years ago. We are in a quiet, nondescript suburb of the Milky Way galaxy. There is nothing special about this place. No giant black holes, no quasars, just a cold molecular cloud drifting through the vacuum. But this cloud is about to die, and in its death, it will give birth to us. A shockwave from a nearby supernova, the death rattle of a massive star, slams into this cloud. The impact disturbs the peace. Gravity, which has been sleeping, wakes up. The dust begins to collapse. It begins to spin. And as it spins, it flattens into a disk in the center. The pressure rises until a new yellow star ignites. This is our sun. But it is not the benevolent father figure we see today. It is a young, violent tyrant blasting the surrounding space with radiation. And circling this tyrant are the scraps, the leftovers, the dust bunnies of the solar system. These are the seeds of the planets. For millions of years, rocks smash into rocks. Dust grains stick together to form pebbles. Pebbles become boulders. Boulders become planetesimals. It is a demolition derby played in the dark. There is no grace here. It is pure kinetic violence. And out of this chaos, a rock forms. It is molten, hellish, and bombarded by asteroids. It has no atmosphere, no water, no life. It is Earth. But it is not ready for us yet. It is a ball of magma floating in the dark. It has to cool. It has to suffer. It has to be hit by a Mars-sized planet to tear off the material that will become our moon. It has to be pelted by comets carrying water from the outer solar system. It is a planet being forged on an anvil. Now, ask yourself, do you feel the iron in your blood? Take a moment to feel your pulse. That rhythmic thumping is the sound of a pump moving liquid iron through your veins. Iron is a heavy metal. It sits in the center of the hemoglobin molecule, grabbing onto oxygen and carrying it to your brain. But here is the secret the universe keeps. The Earth cannot make iron. The sun cannot make iron. The heat required to fuse iron atoms together is so intense that even a star dies when it tries. So, where did the iron in your blood come from? It came from the heart of a star that exploded billions of years before the Earth even existed. That star lived its life, fusing hydrogen into helium, helium into carbon, climbing the ladder of elements until it hit the iron wall, and when it died, it scattered its guts across the galaxy. You are walking around with the wreckage of a dead star flowing through your veins. Every time your heart beats, it is echoing a supernova. This is the intimacy of the cosmos. We are not just living in the universe is living in us. We are a collection of recycled atoms that have been on a journey for 13.8 billion years. Consider the gold ring on a finger. Gold is heavy. It is rare. For a long time, we didn't know how the universe made it. To regular supernovae aren't hot enough. We now believe that to make gold, you need something even more violent. You need 2 neutron stars, the crushed cores of dead giants, to spiral into each other and collide. Here is a number that might scare you. Every gold ring on Earth was forged in the colliding death of 2 neutron stars. The energy released in those final milliseconds is enough to outshine the entire galaxy. It forces neutrons into nuclei so fast that they bulk up into heavy precious metals like gold and platinum. So when you look at jewelry, you are not looking at a shiny rock. You are looking at the fossil of a cosmic catastrophe. You are wearing the debris of a titanic collision that shook the fabric of space-time, long before humans invented the concept of marriage. But the chemistry is just the hardware. The software is the mystery. How did a rock, covered in water and bombarded by radiation, suddenly wake up? How did geology become biology? This is the abiogenesis moment. We still don't know exactly how it happened. Maybe it was in a deep-sea vent where heat and minerals churned together. Maybe it was in a warm tidal pool sparked by lightning. But somewhere, a molecule learned a trick. It learned to copy itself. It learned to encode information. This was the first victory of order over chaos. For billions of years, the universe had been governed by the second law of thermodynamics, which states that everything tends toward disorder. Entropy always wins. Cups break, they don't unbreak. Stars burn out, they don't reignite. But life is a rebellion. Life grabs energy and uses it to build order. It creates complex structures. It fights the decay. For billions of years, this life was simple, single-celled, quiet. The Earth was a slime world, but the complexity grew. Cells learned to work together. Eyes evolved to process the light of the sun. Ears evolved to hear the vibrations of the atmosphere. Brains evolved to model the future. And then, in a blink of cosmic time, a species stood up. A species that didn't just want to survive, but wanted to know why. We looked up at the stars, the same stars that forged our atoms, and we felt a strange recognition. We felt a haunting familiarity. We started telling stories. We started drawing maps. We invented mathematics to describe the curves of the planets. We invented telescopes to peer back into the fog. But what if we are looking at this upside down? We are not small observers. We are the only part of this fire that knows it is burning. We often talk about how insignificant we are. We say, I am just a speck on a rock orbiting an average star. It is a humble thought, but it is incomplete. Because without you, the universe is just a game of billiards played in the dark. A star doesn't know it is a star. A black hole doesn't know it is heavy. The Andromeda galaxy has no idea it exists. Without consciousness, the universe is just dumb matter moving around. It is a stage with no audience. It is a script with no actors. We are the sense organs of the cosmos. We are the way the universe sees itself. We are the way it touches itself. We are the way it marvels at its own grandeur. When you look at the Hubble Deep Field and gasp at the beauty of thousands of galaxies, that is not just you looking at space. That is the universe using your eyes to look at itself. That feeling of awe you feel, that is the universe feeling awe at its own scale. We are the local mechanism for cosmic self-awareness. This brings a heavy responsibility. It means we are not accidental tourists. We are the custodians of meaning. If we were to wipe ourselves out, if we were to let our planet burn, the universe wouldn't end. The stars would keep shining. Gravity would keep pulling. But the meaning would vanish. The memory would be erased. The universe would go back to being a blind, deaf, dumb machine. It would go back to the sleep of the inanimate. The lights would be on, but nobody would be home. We have spent the last hour walking from the Big Bang to the present. We have seen the singularity, the inflation, the fog, the first stars, and the forging of the elements. We have seen that the history of the universe is a history of violence. It is a history of things smashing together, burning, exploding, and cooling. It is a chaotic, dangerous place. And yet, it produced a mind that can love. It produced a mind that can grieve. It produced a mind that can look at the data and say, I understand. This is the great melancholy of our situation. We are trapped in a universe that will eventually die. The stars will burn out. The galaxies will drift apart. The universe will eventually become cold and empty again. The big freeze is coming. We cannot stop it, but in this brief, shining moment between the fire of the beginning and the ice of the end, we are here. We are the golden era. We are the inhabitants of the only time in history where the universe is rich, warm, and knowable. So, when you look up at the night sky tonight, do not feel small. Do not feel crushed by the silence. Feel the iron in your blood humming in resonance with the stars. Feel the complexity of your own brain, which is more intricate than any galaxy. Understand that you are the rarest thing in existence. You are the universe waking up from a long 13.8 billion year sleep. You are the inevitable result of a hydrogen cloud that refused to stay simple. We are not a mistake. We are not a cosmic accident. We are the point. We are the vessel for the story. We are the universe's grief and its joy, finally awake to remember itself.